Welcome to The Explainer. Okay, today we're embarking on a totally mind-bending journey. We're going to explore a reality that is quite literally all around us, yet almost nobody talks about it. We spend so much of our time looking out at the stars on the horizon, but have you ever stopped to wonder what's directly above or straight below our solar system? Well, get ready, because we're about to completely flip how you visualize our place in the cosmos.
So think back to those classic textbook diagrams we all grew up staring at in school. You know the ones, right? The sun is sitting neatly right in the center, and all the planets are perfectly aligned, just spinning around on this beautifully flat, invisible table. It makes the whole thing look so incredibly organized, so simple, just a neat, flat 2D disk. But is that actually the truth of our planetary neighborhood?
Okay, let's dive into this because the reality is fiercely three-dimensional, deeply chaotic, and totally unlike our old assumptions. That whole textbook view? Yeah, it's basically just a convenient illusion. In reality, you've got objects swooping in from high above, diving from deep below, and crossing planetary paths at these absolutely extreme angles. Our solar system isn't some neat little disk at all. It's a wildly dynamic 3D sphere of constant, violent motion.
So here is our cosmic flight plan for today. First, the flat space myth. Second, defining up and down. Third, chaos in the outer system. Fourth, the sun's protective bubble. And finally, galactic mysteries above us.
All right, Section 1, the flat space myth. Let's officially shatter this illusion of a neat, flat planetary neighborhood. To truly grasp how dynamic things are, just look at this massive number, 230 million. Right now, our entire solar system is hurtling through space at a staggering 828,000 kilometers per hour, orbiting the center of the Milky Way. But even moving at that insane speed, it still takes us 230 million years to complete just one single galactic orbit. Think about that timeline for a second. The last time Earth was in this exact spot in the galaxy, the very first dinosaurs were just taking their first steps.
And as we make that massive journey, the objects traveling with us are definitely not staying in their lanes. The main flat plane we use as a reference is called the ecliptic plane, but just look at these orbital tilts. Mars sits 2 degrees off the plane. Mercury dips 7 degrees. Then we get to Pluto, tilted a steep 17 degrees. Asteroid 3200 Phaethon comes in at a 22-degree angle. And the most mind-blowing of all, Halley's Comet has a 162.3-degree tilt. That means it sweeps through our solar system in a completely opposite retrograde direction to the planets. These bodies literally break the flat plane.
Section 2. Defining up and down. Since things are flying every which way, we need some rules to actually navigate all of this.
Because, in the vacuum of space, there's no true ground to stand on, right? No sky to look up at. So astronomers had to create mathematical reference points. Just like we use the ecliptic plane for our local solar system, we use the galactic plane for the entire 100,000 light-year wide Milky Way. Back in 1959, the International Astronomical Union formally established the galactic north and south poles. They ingeniously used our own Earth's celestial poles as a compass to orient the whole system. It gives us a definitive way to map cosmic latitude and longitude. It's just a really clever way to ground ourselves in a completely weightless void, so we can finally say, okay, this is above and this is below.
Section 3, Chaos in the Outer System. Let's move to and see how this builds as we zoom outward from the inner planets into the really chaotic stuff.
Because as we zoom outward, we don't just hit empty space. No, we run into these distinct expansive layers of debris that exist way above and way below the standard planetary orbits. First up, we've got the zodiacal dust, right here in the inner system, basically the dusty remnants of ancient asteroid collisions. Pushing further out, between 30 and 50 astronomical units, we enter the Kuiper Belt, the icy home to tilted objects like Pluto. Beyond that is the scattered disk, reaching out to 100 AU. And finally, the absolute edge of our imagination, the theoretical Oort cloud, stretching out an unfathomable 200,000 AU away.
Let's actually focus on that scatter disk for a second, because this is where things get truly wild. Historically, the giant planet Neptune acted like a massive gravitational bully. Its immense gravity violently shoved passing objects, permanently flinging them right off the flat plane. Objects like the dwarf planet Eris and another one known as 2004 XR190 were knocked into extreme orbits tilted more than 45 degrees. Just picture the sheer angle of those ejections. They spend their entire existence soaring incredibly high above and diving deep below the rest of the planets.
But the true king of 3D space? That's the Oort cloud. 3.2. That's the number of light years this structure spans. To put that into perspective, it's a colossal, spherical shell.
not a flat ring, but a massive bubble, completely encasing our solar system. Because these trillions of icy comets drop in on us from literally all directions, top, bottom, sides, scientists know this massive structure is there, even though human eyes have never directly seen it.
Section 4. The Sun's Protective Bubble. Let's shift our focus from physical icy rocks to the invisible magnetic forces protecting us.
And this brilliantly illustrates how the invisible force known as the heliosphere actually works. Our sun doesn't just emit light, you see, it violently ejects solar winds. We're talking rivers of plasma traveling at an intense 400 to 800 kilometers per second. These winds erupt intensely from the sun's poles, blowing this massive, invisible, protective bubble deep into space. And this bubble is absolutely crucial, because it shields our entire solar system from the dangerous interstellar radiation constantly trying to get in.
To truly grasp the immense scale of this bubble, we can look at our own human achievements. After the IAU mapped our galactic coordinates in 1959, it took decades for our spacecraft to pierce this boundary, which is known as the heliopause. In August 2012, Voyager 1 finally crossed the boundary, exiting high above the ecliptic plane. 6 years later, in 2018, Voyager 2 pierced the bubble from far below. We are literally finally touching the true 3D edges of our neighborhood.
Section 5. Galactic Mysteries Above Us. Now that we've officially crossed over into interstellar space, what bizarre, gigantic structures are waiting for us out in the dark? Well, right now, our entire solar system is moving through a 30-light-year-wide region called the Local Interstellar Cloud. But even that is just a tiny speck inside something much, much larger. We're actually currently inside a massive cavity called the Local Bubble. Spanning 1,000 light-years across, this region is an almost entirely empty void where temperatures reach a blistering 1 million Kelvin. It's fascinating, right? Scientists believe this massive empty pocket was literally carved out by the violent shockwaves of ancient supernova explosions. We are essentially flying through a massive stellar graveyard.
Now, what's really interesting about this is that a 1,000 light-year void seems incredibly massive until you compare the scale to something like the Fermi bubbles. Discovered just over a decade ago in 2010 using NASA's Gamma Ray Telescope, these are two massive, balloon-like structures erupting directly above and below the center of our Milky Way. They're shooting intense gamma rays a staggering 25,000 light-years into space. If our human eyes could somehow see gamma rays, these would be the brightest, most dominating structures in our night sky, towering far, far above our galactic plane.
But the greatest mystery of all has to be the invisible scaffolding flowing right through us. Everything we've talked about so far, the planets, comets, gas, plasma, that makes up only 15% of the universe's matter. The other 85%? That's dark matter. It doesn't emit light, it doesn't reflect light, we can't see it, yet it exists all around us, above us, below us, and straight through our very own solar system.
So the crucial point is, without this unseen 3D structure, nothing we know would exist. Dark matter basically acts as an invisible skeleton that physically shapes our galaxy. Our Milky Way is spinning so incredibly fast that without the massive gravitational glue of this dark matter holding it together from above and below, the entire galaxy would literally tear itself apart.
From wildly tilted dwarf planets and retrograde comets to colossal magnetic bubbles, towering gamma-ray bursts, and invisible galactic skeletons, our universe is absolutely anything but a flat textbook diagram. It's a deeply layered, three-dimensional masterpiece, which leaves us with one final, profound question to think about. If all of this was completely unknown to us just a short time ago, how much more of our universe is hiding right above and below us in plain sight?